Okay. Choose the set of correct options. If V1 and V2 are in the kernel of a linear transformation T, V to W, where V and W are two vector spaces, then V1 plus V2 will also be in the kernel of T. Kernel of T is a vector subspace of V. Kernel of T is a subspace of V. So if V1 and V2 are in that subspace, the as per the vector space axioms, V1 plus V2 will also be present in that subspace. It will also be in the kernel of T. Okay. The next is kernel of a linear transformation T, a vector subspace of V, where V और W और 2 है. यह कर्नल जो होता है वो वेक्टर सबस्पेस होता है V का. ओके. एंड जो रेंज होता है, रेंज ऑफ T इज सबस्पेस ऑफ W. W and W2 are in the image of a linear transformation T, where V and W are two vector space, then W1 plus W2 will also be in the image of T. Yeah, by that vector subspace axioms, if W and W2 be in the image of linear transformation T, and W1 plus W2 will also be available in image of T. And image of linear transformation is a vector subspace of W. This is a vector subspace of W. Okay. Next. Consider the following linear transformation R3 to R2 x y z is equal to 2x plus 3y plus 4y plus z. Question number 2, 3, 4, 5. Which of the following matrices corresponding to the given linear transformation T with respect to the standard ordered basis of R3 and standard ordered basis of R2? It is R3 to R2 transformation, and bases are the standard ordered basis. So we have to get the transformation matrix. For that, write down the basis, and as per the given representation of value, we got the transformation of 100 is 20, and write down this vector in the form of the basis of R2. So it will be 20, it will be 04, and it will be 31. So matrix will be 20, 04, 31. Third option is right. Okay. After that, this next question, third question asking which of the following represents the basis of kernel of T. Okay, for kernel of T, we have to get the null space. So for null space, what you have to do? We have to do the row echelon form. Here, here also is done 2x is equal to -3, z is equal to 1, x is equal to -3 by 2, and y is equal to yeah. For can do like this also, and if you want to convert in row echelon form, then you can also do by dividing it is 2 will be 1, and it will be 3 by 2, and it will be 1 by 4. So from here you will get the x is equal to -3 by 2 and y is equal to -1 by 4. Then the basis will be -3 by 2 and -1 by 4, and z will be 1 because z is a free variable, is independent variable. So you will take the z1, then you will get the x and y value. Basis of the kernel T will be -3 by 2, -1 by 4, and 1. Okay. For dimension of the image, next question is what will be the dimension of the subspace? Dimension is the number of pivot entry, rank, and we can see the 2 pivot entries possible in the transformation matrix. So dimension will be 2. Okay. The next question, choose the correct option. Here nullity is 1. Onto या 1 2 we have to check the t is into या onto. Here the nullity is 1, so it is not 1 1, but for onto we have to check the rank of t. If rank of t is equal to dimension of w, then it is onto, and we can see that its rank is 2 and the dimension of w is also 2 because it's a transformation of r3 to r2. So rank of t is equal to dimension of w, so it is onto. So this matrix will be the onto but not 1 1. This option is right. The next question is the set of correct option. There exists a linear transformation R2 to R2 whose range is contained in the circle x square plus y square is equal to 1. It is a formula of circle, and we clear that the linear transformation range linear transformation of range will not be in the circle form. It should be always in the linear form. So this option is wrong. Okay. There exists a linear transformation R2 to R2 where range equal to the line x is equal to y. Yeah, range can be a line. In R2 plane, we can get a linear transformation of point line. So x is equal to y is possible. R2 to R2 whose range is contained in the set x comma y, x is always greater than 0. If x is always greater than 0, then we cannot get the origin 0 comma 0 value. That's why it's not a linear transformation, because any linear transformation should have the origin 0 comma 0. It is showing the condition x is always greater than 0. Not possible, not linear transformation. It should be something else, with the affine subspace, but not a linear transformation. Okay. The next one, where there exists a linear transformation R2 to R2 where range equals the line y is equal to mx. Yes, it is a possible, because it is a formula of a line, and here if x will be 0, then y also will be 0. So 0 comma 0, the origin is also exist, is a linear term. Which option represents the kernel and image of the following linear transformation? R2 to R2 transformation to xy is equal to x comma xy and x comma 0. यह linear transformation. तो इसका कर्नल और इमेज पूछ रहा है, तो पहले तो हम इसका मैट्रिक्स बना लेते हैं. तो t10 it will be comma 0 and 01 will be 00. This matrix will be 1000. So here the rank is 1 and nullity is 1. So x is equal to x1 is equal to 0 is a null space. So null space will be 0 comma 1. From 0 comma 1 will be, we can get the one is x is always 0, y is always 0, x is 1. So for null space, getting the null space, we have to x0 and y something else. So we can get the kernel of t will be 0 comma 1 will be the span of the null space. The x comma 0 is the range space. 1 comma 0 with the range space. After span 0 comma 1 kernel of t and image t. Here, how you can get the 0 comma 0 is the null space. How you can get the uh, range of this matrix? That will be the image. Range is this vector is the range. 1 comma 0 is the, and 1 comma 0 will be span the image, and here is the nullity. So nullity will be y is equal to 0, y is equal to 0, not x. Y is equal to 0 in null space. x will be 1, x x will be 0 for we equivalent uh, x and y equal to 0 comma 0. So x will be 0 and y is an independent variable, it can be any value. So 0 comma 1 will be which of the following linear transformation is an isomorphism between the vector spaces x y z, x is equal to y minus z, and the w is x y z where x is equal to y. के बीच में हमें देखना है कि ये कौन सा जो ये ट्रांसफॉर्मेशन है वो आइसोमॉर्फिज्म है। कई तरीके से हम चेक कर सकते हैं। तो पहला तरीका तो हम यही देख लेते हैं कि हमारा जो v है और v का जो डायमेंशन है वो 2 है, क्योंकि यहाँ पर दो फ्री वेरिएबल हैं y एंड z, और x को y और z के फॉर्म में लिखा है। तो y जो है और z जो है दो इंडिपेंडेंट वेरिएबल है, तो डायमेंशन ऑफ v 2 होगा। और डायमेंशन ऑफ w देख लेते हैं, x इज इक्वल टू y है, x और y इक्वल है और z एक फ्री वेरिएबल है। तो z हो गया एक वेरिएबल और एक्स वाई हो गया एक वेरिएबल। अभी दो वेरिएबल है तो डायमेंशन ऑफ w भी 2 है। तो हमारा दो डायमेंशन से दो डायमेंशन में ट्रांसफॉर्मेशन है, हालांकि R3 प्लेन में है बट डायमेंशन दोनों का 2 ही है। तो हम ऑप्शंस में से देखते हैं कि क्या कैंसिल हो सकता है। तो पहला वाला ऑप्शन में देखिए तो एक्स वाई जेड, ओके, एंड हियर इज वाई वाई कमा 0। So if y comma 0 will be the format of w, then it will be the dimension 1. So always it is the one variable. तो यहाँ पे देख सकते हैं कि वाई वाई कमा 0 में एक ही वेरिएबल है जिसका डायमेंशन 1 होगा। तो ये ऐसे ही नहीं हो सकता, क्योंकि हमें डायमेंशन दो डायमेंशन वाली चीज ट्रांसफॉर्मेशन। और लास्ट ऑप्शन भी देखिए तो इसमें 3 है डायमेंशन एक्स वाई जेड, और यहाँ भी 3 है, तो 3 डायमेंशन भी चलेगा। टू डायमेंशन से टू डायमेंशन में ट्रांसफॉर्मेशन एक्स वाई जेड को हमने एक्सप्लेन किया है, एक्स इज इक्वल टू वाई माइनस जेड, तो वाई वाई जेड यहाँ पे टू डायमेंशन, तो ये हो सकता है। और देखिए वाई वाई कमा जेड, और हम इस तरीके से और देख सकते हैं कि ये ऑप्शन हो सकता है कि हमें कैसे ठीक। तो वाई वाई कामा जेड, अब हमें चेक करना है कि आइसोमॉर्फिज्म है कि नहीं, वन वन और आन टू चेक करना है। तो हम वाई वाई कामा जेड से देखेंगे, अगर हमें वन वन के लिए हमें सेम डायमेंशन डायमेंशन में ट्रांसफॉर्मेशन हो रहा है, तो जीरो 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 हमें ऑलवेज विल लैंड्स ऑन जीरो जीरो जीरो। तो हम जीरो 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 से देखेंगे जीरो जीरो मिल रहा है कि नहीं। अगर हमारा डब्ल्यू जीरो कमा जीरो है, यानी कि वाई और जेड जीरो है, तो हमारा जो वेक्टर वी में एक्सप्लेनेशन है वो है एक्स इज इक्वल टू वाई माइनस जेड, यानी वाई माइनस जेड कमा वाई कमा जेड। तो अगर हमारा डब्ल्यू जीरो 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 है तो हमारा वी भी जीरो 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 आ रहा है। तो जीरो वेक्टर लैंड्स ऑन जीरो, तो इट इज ए वन वन ट्रांसफॉर्मेशन बिकॉज इट इज ए सेम प्लेन। तो अगर सेम प्लेन में वन वन है तो ये आन टू भी होगा। तो ये वाला हमारा जो है सेटिस्फाइड कर रहा है डायमेंशन साइड से भी और वन वन और आन टू साइड से भी। तो ये वाला ऑप्शन नंबर 2 हमारा आइसोमॉर्फिज्म होगा। So the following linear transformation is an isomorphism between the vector spaces V and W. Some conditions are there. This is the same question, so we can go through the same way. Here x y z is equal to x is equal to y minus z is equal to 0, means x is always 0 and y is equal to z. So here only one free variable is there, so dimension of v is 1 and dimension of w is x is equal to y is equal to 0, x y always be 0, z can be take any value. So the dimension of w is also 1, so transformation is from one dimension to one dimension only. So let's check the options. The first option is saying x comma 0 comma y is a one dimension or two dimensions. Please check the how it is explained. W is x is equal to y is equal to 0. So it is written x, but its value is equal to y and it will be 0. So it will be 0 comma 0 comma y. So here is a one variable only. So this dimension is 1. Let's check others. Here 0 comma y comma z. Okay. So x and y will be 0. Okay. X 0 and y will be 0 and z will be the one variable. But what is the problem there? The next is 0 z. Option 1 x comma y comma z is x is equal to y minus z. So it will be 0. So it will be 0 comma y comma y. 0 comma y. Dimension 1. On right hand side will be x comma 0 comma y will be 0 0 y. So dimension 1. Right. Option 2 x y z is equal to 0 y y, because here x y z from left side it is x is equal to y minus z. So x is equal to 0 and y is equal to z. So x y z will be 0 y y. Dimension 2. Dimension 2. So dimension 1. 0 y y dimension 1. And right hand side 0 y z. 0 y z. And it is said that x is equal to 0 will be 0 0 y. No? So here the right hand side will be 0 comma y comma z will be 0 comma y, because our z is equal to y from this side. It will be 0 comma y form, but we have to get the form of 0 comma 0. X and y both are 0. x 0 तो y भी 0 होना चाहिए और z होना चाहिए, 0 0 z होना चाहिए हमारा, जबकि इस फॉर्म में, जबकि हमारे जो मिल रहा है वो 0 comma y. So z is if z is equal to y, so it will be 0 0 y, जबकि इसके अनुसार ये होना चाहिए 0 y होना चाहिए, क्योंकि हमारा 0 0 y हो रहा है. So it is not equal. That's why the second option is not possible. And the third option saying 0 0 x, and from v we have the x y z is equal to 0 y, because x is equal to 0, it is given. So if the w will be 0 x, then it will be 0 0 0 vector. So all the vector will lands on 0. So third option is also not possible, because it will become the 0 0 0 format. Okay. So let's check the isomorphism condition. For isomorphism, we have to check the 1 to 1. All 0 0 all 0 vectors would be lands on 0 if the same dimension is there. So if v x y z 0 x is always 0, and if y minus y is always y is also 0, y is equal to z, so z will be also 0. So if 0 comma 0 comma 0 means x 0 y 0 z 0, then this transformation will be 0 comma 0 comma 0. It will lands on 0. So it is 1 1. This is we get the linear transformation, and this is 1 1, and the dimensions will be on 2 also. So this will be the isomorphism. Okay. The option satisfied the isomorphism condition, because 0 vector lands 0 and it is same dimension, so it is 1 1 and both. Okay. Next question is, consider the linear transformation T R3 to R3 such that x y z is equal to x minus y plus z to x plus y minus z minus x minus y plus 2z. Which of the following options are true about t? Okay, we have to get the matrix T first. It is asking for range and rank. So it is R3 to R3. So write down it's the standard order basis form. 100 will be 1 2 minus 1, 010 will be 1 2 as per this expression. And if we express this transformation into the standard basis format, so it will be 1 2 minus 1 minus 1 1 minus 2 1 minus 1 plus 2. So the matrix will be 1 2 minus 1 minus 1 1 minus 2 and 1 minus 1 2. We perform the row reduced echelon form on this matrix. We will get finally 0 1 0 0 0 1 minus 1 0 0 0. So you can see here two pivot entries there. So rank will be 2 and nullity will be 1. Then let's the options what are the asking. Rank of t is 2 or 1. Rank of t is 2 because 2 pivot entry, and range of t. Range of t is the will be spanned by the independent vectors which have the pivot entry. So first two column have the pivot entry. So first two vector will span the t. It will be the range. First two vector is 1 2 minus 1 minus 1 1 and 2. So we have only two bases, rank of 2. Pivot entry are in the first two columns, so of space range space will be spanned by 1 2 minus 1 and minus 1 1 minus 2. And the option saying that first of x is equal to y plus z satisfied the basis condition. The first option, the two options are there for range. First one is x is equal to y plus z, second is x 0 y plus z 0. So we can see x is not here 0, and the first is x is equal to y plus z. So 1 is equal to 2 plus minus 1 and minus 1 is equal to 1 plus minus 2. So this is satisfying it. So range will be the first option is correct for the range of t. Okay, so this is the last question. Thank you.